In particular, we will use the Microsoft Excel, all right? We learn how to use it, okay? How to put in your problem and how to set it up and what buttons to click and get a solution. Is that okay? So, not my favorite type of activity, but it's useful to be able to do that because you take advantage of other people's intelligence and you build on top of that, okay? All right, so I have the Appendix E from the textbook. My plan is to go through one example in some detail and another example rather brief, not too much detail. Hopefully through those two examples, we shall be good, okay? And Microsoft Excel is available on all computers on campus. So if you don't have it on your personal PC, there will be homework problems asking you to do this in Excel just for me to check to know that you know how to do it. Then go to a computer on campus and do it there. Plan your time ahead. Is that clear? All right? Okay. All right, so today is how to use Excel. Okay, so we'll go through two problems, examples. So let's take the first example. This is actually a more complicated one, but it's good to take it like that, all right? So if you have the book, it's in the appendix. Otherwise, I will explain. I will put information on the board. So this is like a product example that you are producing stuff. And you have processes that you can use to make these products. And you use resources, which is labor and raw material. And there are requirements and so on and so forth. So let's put everything in a table form. So in particular, I have 4 processes. So let's call it process. I have 4 of them. Let me list everything in the table. I have process 1, 2, 3, 4. Okay? And then what I have as resource, or you can call it input, what I put in will be labor. It's hour per worker, so that's clear. And then I have 2 types of material, material A and material B. Okay? And then each process or processor, what should I use? Is it process correct or processor? Processor. I'm not English, so processor, that sounds better to me, huh? Okay, so number 1 would use certain amount of resource. It needs certain labor, it needs certain material. Let's put this information in. So I need 8 hours, 160 unit of A, 30 unit of B, and for 2 I need 10 hours, 100 of A, 35 of B, and 6 I have 260, and 12, 75, and 80. So that is the material resource it will use. And then as a output, it will make 2 products, certain amount. So product 1 here and product 2 here. So I'm going to set everything up in the table. So for processor number 1, it will produce 35, 55 of them, 45, 42, 70, 0, 0, 90. Okay. This is like the core part of the information. Okay. And then you have other things. So to use these 4 processes, there is a price, there's a cost. Okay. So which is what we want to minimize. So the cost to use each processor, so $1 per hour, whatever, unit of money, unit of time, it's given as 400, 575, these are just numbers, 620, 590. Okay. Anyone has a textbook with you? Anybody? Let's check. Don't want to punch in the wrong numbers. Okay, yeah, thanks. All right, then there are other constraints which I will list over here. So the resource is not infinite. There is a limit for them. I have maximum amount of certain things. So I have maximum amount of labor, maximum amount of material A, and material B. So these are limits. Okay? I don't have infinite amount of it. And then there are requirements that I need to produce certain amount of these two products as an outcome. I must do 1300 of product 1, 2600 of product 2. So these are requirements. Is that clear? Mm-hmm. And then there is one additional thing that's being added to this model. So my table ends here. So that's that. Now, there is an option for me to buy the product 2 already made by some vendor. It's possible to buy it. And so the price, there's an option here. So price for buying product 2 already made, okay, is $18 per unit. So it might be advantageous for me to just buy it. It might be cheaper than for me to produce it. Okay, then probably I will buy some. Is that clear? So now the question is, how many hours of each processor should I use? So let's define the variables. X1, X2, X3, X4 will be hours to use for these processors 1, 2, 3, and 4, and plus how many to buy if I choose to buy, okay? Number of product 2 to buy, okay? And then your goal is to minimize the cost. Okay, so it's exactly the same example as in the textbook. So you might just want to listen, and you don't have to copy all these. All right. Okay, so let's practice our modeling skill. Take this as a problem that we set up the model. Are we okay? So process 1, I'll be using X1 hours, and this is X2, and this will be X3, and this will be X4, the hours I will use, okay? And I try to set up this linear programming problem. Okay, so minimize the cost, so minimize, can I set up my cost function? How much will it cost me if I use X1, X2, X3, X4 hours of these processes? So for process 1, it costs $400 to use it for an hour. If I run it for X1 hours, the price will be the product. Is that right? 400 X1. And you do the same thing for the other, and you add them all up. Is that clear? We've done this modeling part many times. So the price for using processor 1 will be this, and 2 will be 575 X2, and to use processor number 3 is this. To use number 4 is this. So these are the prices for using the processors. And then there is an additional price because I have the option of buying product 2 already made and let's say the number of product to buy, this one here, I call it another variable, x5, will be the number of units of product 2 that I buy. Is that okay? So that comes with the price, right? So each one costs $18, and I buy so many of them. Is that clear? That's the cost, how I got it? All right, constraint. I actually have quite a few constraints. So first type of my constraints come from the limit of resource. So I have some, the total labor cannot be more than that, and the total material cannot be more than these. So I will set this up. So the total hour I would have will be 8, x1, 10, x2, 6, x3, 12, x4. That will be the total labor, right? Is it clear? That shall be less than 450. Okay, that's labor. So for material A, I have 160 x1, 100 x2, and 200 x3, and 75 x4, and that shall less than equal 4200. And for material B, 30 x1 plus 35 x2, 60 x3, 80 x4. And that I have 2,000. So these are coming from the limits that are listed in the table. Is that clear how I get each of these inequality? Any questions on that? Okay. I assume it's okay since you all did so well in the exam. You don't want to answer my question. It's okay. I'll keep asking. Okay, and then we have the other two requirements coming out of the requirement for the output. I have to make these products, right? So product 1, I will make this many, 35 x1 from processor 1, 45 x2 from processor 2, 70 x3 from processor 3, and processor 4 doesn't do anything, and this must be bigger than or equal to 1300, right? At least I have to make that. Okay, and then for product 2, let's copy that down. 55 x1, 42 x2, no x3, and 90 x4. So how many of product 2 will I have? All of these, this sum here will be, the 4 processors will produce that many, right? But then actually I also buy some, don't I? X5 is the number that I buy it from some vendor that's already there. So I will add that on top. That shall be meet my requirement, 2600. Is that okay? So these will be requirement. All right? Note that these has the bigger than equal sign, and these 3 has less than equal sign. Kind of different type of constraint. And then I have all the variables shall be non-negative. Okay. Is that okay? We able to set this up by ourselves? Maybe I should have given a modeling problem like this in the exam instead of that super simple one. We can handle this, right? Okay, now, from the knowledge we already have, we know that I could rewrite this into standard form by adding slack variables, right? Make it all equal. And then I can add artificial variables, make it into canonical form as needed. Then I can put it into LP Assistant, and I need to figure out where to click and where to click. I can solve it. Is that right? Are we confident we can do that? It will just be many constraints, many variables, but we can do that, Okay, so that's one way of solving this. It requires your knowledge. You need to know where to pivot, where to click. Okay, so today we're going to look at how to do it in is it warming up? Okay, I'll try it again. Let me put the screen down. Okay, my computer is messing up with my computer. Okay. Okay, it's coming. So let me put the screen down and turn that off. And turn that off. Okay. So this is already made, but I am going to show you step by step how can one set up this problem in Excel as the first example. Is that okay? The second example, I will not go into such detail. So I'm going to open a new sheet. Have we all played with Excel before? Have we all used it? Yes? No? For me, my prior knowledge of Excel is I use it to compute the grades. It can do average. It can drop min and max, which was very convenient. That was all. I did not know it had so many other options. It actually is capable of doing a lot of things. There are even workshops on training you on how to use Excel. Okay, so full respect to Excel. Okay, so is this big enough? Should I make it a bit bigger? Is it enough? If I type in, can we all see? Okay, so let's do this. So I have my. So you will see that in Excel, what we will put in will be more or less the information in this table. Okay, you don't see the equations, and the equations you would put in like rules to the program to solve. Okay, so let's say example. Let's just call it a product example, whatever. So let's see if I can put that. So I see what I have. I have to put in information about my processors. So let me just label. This is just for your own, you can see what's happening here, all right? And then I need to put in the input. Let me label this. That's my input. What do I have? I have labor, I have material A, and I have material B, okay? And then I have 4 processors. Let me label them 1, 2, 3, and 4. Is that okay? I'm just putting there, okay? And then for each type of input, okay, let's don't do that. Let's put in the input first. Okay, so I'm just punching in these numbers. Let me hope I punch it right. 8, 10, 6, 12. That's the first for labor. And 160, 100, 275. That's material A, right? And material B will be 30, 35, 60, 80. Okay? And that's the input part. And then I also have the output that I make the 2 products. So product 1 here and product 2 here. Okay? So I punch in the second half of that table. So process 1 will do 35 of these and 55 of that. And 2 will be 45, 42. And 3 will be 70, and 0, and 0, 90. Is that okay? That's the first part. And then I will put in the cost for using each processor. And you know that's $per hour. You could choose to write it as $400 with a $sign, so it's clear to you. The program handles it with or without the $sign. It's irrelevant, all right? It's all just for your own clarity, you write it. So the second one is 575, and the third one is 620. Did I put right number? And the last one is 590. Is that okay? And I have another cost, that is, if I choose to buy product 2, price, if I buy, okay, cost, if I choose to buy it. Okay, is it okay, price? It's all just, okay, vendor price, that you buy it, vendor. Okay. So let's say I will put it in this cell eventually. Okay, so I know that will be the cell. I will put that. Okay, let's put that in. That's actually given. So it's $18. Okay, and still have to put on the right hand side. I know what we'll have for the input will be limit. It's limited. So 450 total labor, 4200 total material A, 2000. Material B, and then I have requirement. I need to produce certain amount of product 1 and product 2. Okay. So I put all the whole problem in, the information that I have. Is that clear? This is the part you put all the information in Excel. Okay. And now you go into the setting up the problem part. You need to, we declare some variables. So let me put my variables here. You can put it anywhere. So let's say my variables will be here. They will be processor, numbers, okay, that define 1, 2, 3, 4. These are the 4 processes. And my unknown will be the number of hours that I will use it, right? So this cell, these 4 cells, this one here, this one here, and this one here, and this one here, those will be my X1, X2, X3, X4. So I know I will use those ones, okay? And then I have another requirement, that is how many number of product 2 I will immediately purchase, right? I will not produce it, okay? So let's say this will be in this cell. You can just pick any cell. You have to mark it with this so you know where you picked as that, okay? And then we set up what we want to do is to minimize the cost, and I will specify the cost here, okay, so that you all know. All right, and then you need to specify your constraint. Let's write it. So constraints, they will, I know from what I set up there, I have 5 constraints, 3 coming from the limits of material, 2 comes from the requirement. So let me label those so I know. So 1 coming from labor, and 1 coming from material A and material B, and the production requirement for product 1 and for product 2. Okay, all these are just labeling for yourself. Okay, and let me say that this will be the left-hand side of my constraint, and that will be the right-hand side of my constraint. And I know that for the first one is less than equal, second one is less than equal, third one is less than equal, and this is bigger than an equal and bigger than an equal. This is all for your own visual thinking, okay? In the end, you have to put the rules in it, so it's not... Okay, so let's see, how can we put the constraints? Okay. Can we all see? This visible is okay? Yeah. Okay, so remember the equations we set up. So for the labor, now we use, you punch the equal sign, and then you launch this calculation mode in the Excel. So we will remember the label, it's like, how do you compute? It's kind of like take this 4 number as a vector, and you do a vector inner product, dot product with the vector x1, x2, x3, x4, and get one number. Is that right? Do we notice that? Okay. And there is a built-in function that's called sum product. It takes a vector, 2 vectors, and just compute this product. Okay, so you use that, and then you send in the first vector. So this is the labor. So the labor, you will take the first cell, you make a vector all the way to the last cell. Do you see that? C4, column F4. And then it takes those 4 numbers and form a vector. Okay? And this shall be dot product in the product with your variable. From here, column, the last one, here. Is that okay? Is it clear? It has to be clear because this you use over and over and over. Is it clear how I did it? Well, you can type in instead of clicking. Clicking is just more visual. Okay? So we're done. So that's the first one. And the right-hand side should equal, where do we get the right-hand side from? Is from this cell, right? You can just click it and it will pick it. Okay? And it will take the number. Is that clear? Okay, now let's do the same thing for material A. Now it's repetitive, so I do the sum product. I choose that, and this is for label, so I will start from here and here. That's my first vector, and then the second is always the same. Start from here and here. So that's my second. Is that clear? Okay. Where will I pick the right-hand side? Which cell should I pick it? This one. Is that right? You can write G5 or you can click on it. Okay? Then I have that. All right. And now let's do the material B. It will be the sum product. So I will be doing B. So from here to here, comma, and then from here to here, return. I got that. And the right-hand side equals this cell. That's where I get it. Don't type in the right-hand side. Make it equal that one. Then if later on you want to play with this model and go and change a number, this here will be automatically updated. All right? So product 1. Where would I do my sum product? Well, it's these 4 values. So this one all the way here, that's the left, and then again this one here. Is that clear? And what will be the right-hand side? Equal, I get it from here, right? Okay. Detail is also in the appendix. Okay, I do another sum product. For the product B, I will take this vector all the way to here, those 4 numbers, and the product with these, my 4 variables. But then for product 2, I have an additional term because the number of this, I need to add also x5 to it, right? So whatever how you do it. So I will just move here and add x5. Where would that be? Well, I said I chose this cell to store that information, right? You can just go and click it and it will take it. Is that okay? So that's done. And then the right-hand side equals, that's where I get the right-hand side from. Okay. So now I kind of set the framework for the constraint, except I haven't told it yet exactly how the constraints are. Those will be given when you set up the solver. Okay, one last thing to do is to set up the objective function, the function that you want to minimize. Is that right? So that is, again, a inner product of 2 vectors, of those x and of the price that's given for the processors, right? So do another sum product. Let's choose that. And I will be doing the price as the one of the vectors. And then my x, 1, 2, 3, 4. But that's not all, because I also have to add the price I pay for buying x5 units of product 2, right? Then you can add. So what's the unit price for the product 2? Well, it's in this cell, right? I can just tick it, and I pick that and multiply by how many? It's this cell, right? I define my variable here and take that. Okay, so now I defined everything. Right now you don't see the values because it's not solved, because these numbers are not given and these are computed based on these numbers. Is it okay? And this will be the thing I will minimize. Okay, so now you set up the things all there in Excel, and what you do next is to launch the solver. Depending on the version of Excel you have, you might have to download it, but it's all free. You can install it. And for me, I have it. I think for many of you, it will be in these tools. If you go down, you will have this solver. Okay? You launch it. Okay, here you need to describe your constraints and what you want to do. So where is the objective cell? The objective cell I see is this one, which is D18, and it's there because I had my cursor on it when I launched the solver. If not, you type that in. You can go and change it and type it in. It's okay? And then you decide, is this a maximization problem or minimization problem? Well, I am minimizing, so I have to change it to min. All right? And what are the variables for me to adjust to for the costs? Basically, where are x1, x2, x3, x4, and x5 for this problem? Okay, then I need to specify. So I know my x's are those 4 and plus this one. Is that right? That's what I agreed with myself. So let me type it in. So that will be, mark the syntax. You have to type in like that. C in the row 15. You can put semicolon to take a vector, and C, D, E, F, and then I will have $F and $15. That picks the 4x1 to x4 and comma, and then I have another one, right? x5, which I agreed would be on D 16. Is okay? Now we specified it. Okay, and then I need to add the constraint. Constraint, so you click add, and now it pops up this window for you to add constraint. Now you see you can specify if you want less than equal or bigger than equal. This is determined here, okay? What you typed in there, less than equal, is only for your own visual convenience. It has no saying. Is that clear? So there you decide. So here I have less than equal. So since I have two types of constraint, 3 equations less than equal, the other 2 is bigger than equal, I'll do them separately. So I put my first type. I will declare these 3 cells. So it will be $C, $21, all the way to $C, $23. So that picks 3 numbers there, right, on that vector. And that shall be less than or equal to these 3 cells. So you define. So that's E. Is that right? 21 and E and 23. Is that okay? You can say OK, and this will be, let's do that. If I click OK, you see the constraint is listed here. But then I have more, right? Let me add another. Then that will be these 2 cells, so C24, so all the way to C25, 2 of them. And now I have to change this into bigger than equal to. Is that clear? Okay, then these will be E24, E25. So E24, E25. And click OK. Now you have all the constraints. Put it in the solver. Okay, is it clear? All right, now you choose your solver. We choose the simplex linear program. It's a linear problem. Okay, as you see, Excel can handle many other problems, which we don't cover in this course. Okay, nonlinear, it can optimize as well. Okay, and now it's a scary moment, because now I need to, it's the time for me to click this solve. It's always scary. Will it work? Should I click? You've been following? Did I punch in all the numbers correctly? You've been double checking whatever. Let's see it solve. I click on solve. Okay, and then it solves, and then it tells me that solver found a solution. All constraints and optimality are satisfied. So it went well. This LP problem has a solution. And the solutions now, they are shown in here. So you know you need to use that many hours of processor 1, processor 2, processor 3 you don't use, processor 4, and this is how many units of product 2 you should purchase, and this is the minimum cost. Is that clear? Okay. And at this point, you can say keep solver solution or restore original value. I always do that, because if I keep the solver, then it will override all the rules that are set in, which I don't want. I can always click solver to get the solution. So I will do this. And you might also have noticed that on the right-hand side, it could write you some reports of how things went, and answer report will give you detailed answer, and in particular there is the sensitivity report, which we'll not look at it now, but later on we will talk about sensitivities of the problem. Meaning, if I change a little bit of data, let's say I change the price of this a little bit, or something I change a little bit, will the answer be pretty close to the previous answer, or will it change dramatically? So how sensitive is your answer to the data? Okay, we'll talk about that maybe in not next chapter, next chapter it will come. So is that okay? We'll be able to do this? So this is a detailed, I show you in all detail how I go through all of that. So do you like it? Do you like to click and punch and put, you know which cell to put what? So you don't know how the thing is solved, right? It's a black box. You put an input and it spits out output. You have no idea what it is doing, which is good and bad. It depends on how you view it. Okay, so any questions on that? Is it okay? So do you want another example, or you think that's enough? It's up to you. I can go through another example, maybe not in so much detail, pretty brief, just to have another view of this. Would that be desirable? We want that? Okay. I can do that. Let me blank screen that. All right. Now, in the chapter, what's the chapter number in the textbook? 3.10, there are several examples the author gave, and with answers from problems solved in Excel, the output of it. So what I will do we'll take one example and go through it pretty brief, because once you get a hang on it, you know, all you need to do is put this in the Excel. You don't really need to set this up on paper. If you have it in your head, you know what to do. It's pretty standard, right? Okay, so next example we'll put a table up and we go to Excel and punch in the number right away, all right? Okay, so this is an example taken from the textbook, 3.10.1. There are 3 examples there. I'll cover the first one. I will ask you to do the second and the third. Follow whatever's in the textbook to make sure you know how to use it to obtain the same answer. It will be part of the homework. Okay, so just to make sure. Okay, so here is, again, to produce in a similar setting. Okay, so I need to produce 3 types of products, 1, 2, and 3. Let me set this up. And then it needs some material, some components. Let's just say that's material. I have 4 types of material or components I need to make these 3 different products. And let's put the number: 16, 30, 28, 24, 40, 36, 30, 50, 32, 10, 20, 15. Okay. But then I have limits. I don't have that many of, I have limited supply of each material. So let's put the limit in. And 2044, 2438, 975. And then for each product, I can sell it, provided I could sell all of it. I have a profit, right? So per unit price that I can sell, which is given 78, 136, 104. Okay, so these are money. Let's put the dollar sign. So the question now is, okay, in this situation, with the limited resource and the price tag on each product, how many of each should you produce to maximize your profit? Is that clear? So how many of each product? So product 1, 2, 3. Okay, so let's declare these as my variable, x1, x2, x3. So how many of each should I do to maximize the profit? Okay. So is it clear, the setting? If you want, you can go ahead and write out the linear programming. It's a very standard modeling problem. It is done in the book. Actually, the author did that. Okay, we think we are professionals. We're not going to do that. We'll go to Excel, go straight to it, and set this up. Is that okay? Okay. So I'm not going into detail as I did for the other problem, so let me show you what is being set up. So this is how it is being set up. Okay, I punch in all the numbers on the table over here. This is just basically the table. I labeled it, I put all the numbers in. Okay, then I declare 3 variables. The number of products 1, 2, and 3, how many of them I should make. Okay, these are my variables. Okay, and then I declared my max profit. This is, you see, it's declared again as sum product of that row is the x1, x2, 3, and this is the row number 8 is the price. So that's the total profit. Is that clear? It's always this inner product of 2 vectors, right? Let me put it a bit lower so we can see the whole table. And then I know I have 4 constraints because of my materials limited. Okay? And you see these right-hand side, they are just taken from these supply, the limits here, those numbers. This one is F4, F5, F6, F7. That's all. Okay? And the left-hand side, they are given as again, the sum product. Okay? The vector in the product vector of your X and the corresponding row here. Is that clear? So this, would you be able to set this up by yourself? So that is the row for material A, and I go down, and that's the row for material B, and you see that picks the row for material C, and see that picks the row for material D. Okay? And then I put this on that, and I launch the solver. Okay? So once you put it in something in the solver associated with the problem, it remembers. Okay, so this is, I have already put it in, so the objective is this cell, C14, which is here. So be careful with the syntax. You have to punch $C $14 to say that's C14, okay? And this is a maximization problem. The variables, they are here, 1, 2, and 3, CDE12. So from C12 to E12. And then my constraints are here, that one, C17 to C20, C17 to C20, less than equal to there, E17 to E20, which is marked here. Is that clear? And the solver, we choose simplex, all right? And then once you set everything correctly, and all you need to do is click a solve, and if it has a solution, it will find it. See, it's found, all constraints are met, it will tell you. If it doesn't find, it will tell you it cannot find, or if it's not feasible, it will tell you also, all right? And then you know you have to make 10 units of 130 that, and that's your maximum profit. Question?
If you were to choose something other than the simplex method, would it give you the same answer?
Your problem is a linear problem. Simplex method is the fastest one to do that. Okay, you want, I didn't try the other one, let's try it. It's just a tick and a scary click on solve. This is for nonlinear problem. Our problem is linear. It will be way overshooting. And evolutionary, I don't know what that is. Let's try a nonlinear one. Usually nonlinear one is able to handle linear problems. Let's see what will we have. Do you remember the number we got earlier? Yeah, it's the same. Exactly the same. Okay. Yeah, it's like shooting a chicken with a cannon. Is it clear how to do this? I will ask you to repeat the second and the third example in the textbook and get the same result as the textbook indicates, and that you include in your homework. And then there's problem 1 in that section. You go back to example 1 and you change numbers, and then you find new solutions. Is okay? That will be part of the homework. All right, so that's that. All right, any more questions on this? Are we okay? I will have 10 minutes. This takes so long. Every time I repeat it, takes longer time. Can you explain to me why that happens? I thought it would be faster. I was trying to be faster. Okay. Let's take a sneak peek of the next topic, which is a big deal, the duality. So 2 important concepts associated with the problems here. The one was the convexity, which we covered, and the second is duality. Okay, so that's chapter 4. Has anyone heard of this name, a dual problem of something, in other math course you take? Or anything? Bless you. We have heard of the dual? No? Okay. It appears in many different places for many mathematical problems. It's a kind of a big deal, and it's hard to explain what it is. Okay, so let's make an attempt trying to understand. do a really introduction. Take a word problem, set it up, and try to set up the dual and see that it's basically the same problem but viewed from different angles. Okay, so we'll revisit a blending problem that we covered. I think maybe one of the first example of modeling. I think it's in the textbook 221. Okay, so the farmer needs to buy 2 feeds to feed his chickens, and there are 3 nutrition elements that's important. Okay, so remember that. So I have nutrients, important ones, A, B, and C. Okay, and then on the market there is a shop that sells 2 feeds, feed 1 and feed 2. And then here's a table of the nutrition value: 3, 7, 3, 2, 2, 6. All right, that's that. And then for each feed there is a cost. I think you remember this example. We went through this, did we, or not? Each feed has a cost, and then there is the minimum requirement. So you must give 60 units of nutrient 1, A, 84 of B, 72 of C, otherwise your chickens will get sick. All right? And so the question for the farmer would be, how many of feed 1 and feed 2 should you buy to meet the standard and to minimize your cost? Remember that problem? So let's say, let's say, so this is the problem viewed from the farmer. Okay, that's what we are used to. So let's set this up. So x1, x2, these are number of pounds or whatever, just for the amount of feed 1 and 2 that you would buy. Okay, and then you want to minimize your cost. Minimize, I'll just set this up. I think we are all familiar with that. So 10, x1, 4, x2. That will be your cost, right? Now you're adding vertically up. Okay, subject to, what's the constraint? Well, the constraint is there's a requirement here for the nutrition elements. So for A, 3x1 plus 2x2, that has to be at least 60. And for B, 7x1 plus 2x2, that has to be at least 84. And 3x1 plus 6x2 bigger than at least 72. And then I have x1, x2, non-negative. Is that right? That's one of the very basic models that we started with. Okay, and you can solve it by graphic method or whatever, and it is found the minimum cost is 144, obtained at 621. So he should buy 6 units of feed 1 and 21 units of feed 2. That will minimize his cost. Okay, so that's we call this the original problem, viewed from the farmer's perspective. Now we're gonna view it differently. Now, so the farmer has been buying these from a store in town, and then there is a new salesperson or new store opening up, a competitor, right? So now we view this from a competitor point of view, competing seller. Okay, so this guy, he's selling, okay, tablets. Okay, they're in tablet form. Each tablet contains 1 nutrient. So he has tablet type A. Each tablet contains 1 unit of nutrients A, and same for B and same for C. Okay, And okay, the tablet contains other things, but those are the basic ones. And then he wants to try to convince the farmer that buy my tablets, don't go buy these feed and feed them to the chicken. I'll give you a competitive price. Is that clear? So sellers, so sell tablets of nutrients A, B, and C. So to be convenient, each tablet, let's say 1 unit, all right? So, and then for this seller, he has to decide the price on these tablets, right? How much do I charge for each tablet of A, B, and C, so that he could remain competitive for the farmer, and also he must meet the minimum requirement of nutrients for the chicken. That has to be met. Is that clear? So let's label that. So his variables now, we call them y1, y2, y3. That will be the price for these tablets, okay, A, B, and C, okay, respectively. Okay, so he wants to maximize his profit and meeting the minimum requirement. So let's say, what will be his profit function? Maximize. He knows that to meet the minimum requirement of nutrients, the farmer will have to buy a total of 60 tablet A, 84 tablet B, and 72 tablet C, right? Add that up, that will be his profit. Agree? So the profit will be 60 y1 plus 84 y2 plus 72 y3. And he tried to maximize that. He wants to make money, of course. Okay, so what will be his constraint? Well, the constraint comes from the fact that he wants to be competitive. If his things are too expensive, the farmer won't buy it. The farmer will just go to the old store and buy this feed 1 and 2. Is that right? So if you give the tablet the nutrition equivalent of what feed 1 offers, so how much would that be? If I want to have the nutrition that feed 1 offers, then I need 3 tablets of A, 7 of B, 3 of C. What will that cost the farmer if he buys the tablet instead of the feed? That will be 3 y1 plus 7 y2 plus 3 y3 by the pricing. Is that right? So the farmer would pay that much if he buys the pills instead of buying feed 1, which will contain the same nutrients. So for the seller to be competitive, this should not be higher than 10. Otherwise, the farmer will go and buy feed 1. Do we agree? So that shall be less than 10. Is that clear? That's important. So this inequality I have is for the farmer, for the seller to be competitive. Okay, otherwise you won't sell your stuff. Is that clear? Then I have a similar one for the feed 2. If the farmer buys feed 2, he pays 4 cents. If he doesn't buy feed 2, he uses my pills, he needs 2, 2, 6 of A, B, and C. How much will that cost him? 2 y1, 2 y2, and 6 y3, and that must cost less, otherwise he won't buy from me. Is that clear? Okay, and then I have the non-negative constraint. Okay, so we see that clearly this problem is related to that one, actually closely related to it, because it's exactly formulated with this problem in mind. Okay, so you have just seen the first example. So let's call this 1. Let's call this problem 2. I will just kind of tell you 2 is the dual of 1. And later we'll give a clearer definition. Right now it's just... So it's kind of the same problem, but viewed from 2 different angles. One is from the farmer, one is from another seller trying to sell his stuff to it, right? So an interesting question you will have in your mind will be the following. Do you think they will make a deal in the end? Will they make a deal? That would depend on the solution, isn't it? So the seller will be solving this problem and to maximizing, and he'll find a solution. So when do you think they will reach a deal? If I find a solution here, how much profit I will make? If that matches for this problem, the farmer had an option of going to the shop and to minimize it. If they match, then the farmer say, well, I have nothing to lose, I will make a deal with you. Do you think that's a reasonable thing to say? Okay, it's too preliminary. We'll get into the details and play more with the duality in the following weeks. Okay. Now don't forget to turn in your homework. There's a homework due today.